So what are abstract classes? They're used to describe a concept, a partial implementation, or something that's not completely known, but has partial known aspects. So a good example is a car. We're going to make the presumption that all cars will drive using the gas pedal. They'll all have the same radio and same handbrake, but each car will have a different way to move the seats and windows, and we'll calculate their speed differently based on the wheel size. Next, we'll need to implement two versions of the abstract class. So we're going to take a budget car and a sports car. They'll both automatically inherit the implemented methods of the abstract class, so we don't need to be redone. Next, they'll each implement their own version of the abstract methods to move their seats and windows and calculate their speed. The sports car will have electric seats and windows, and the budget car will have manual adjustment. The sports car has bigger wheels and a larger engine, so travels faster. The green methods are the methods that the abstract class implements and are identical for all classes. The black methods are abstract unimplemented methods in the abstract class that get implemented in blue in each class that inherits from the abstract class, so are unique to each class. Okay, so let's make this actual abstract class and the budget car and sports car to see how this thing really comes together. So I've just started a new console application, and in here we're just going to do it all in one class for now, just keep it simple. So let's start by making this abstract class. So you make a class as you always would, like this, say class car, and there's your class, and just simply prepend it with abstract. So now an abstract class cannot be created. So if we went in here now and did var a equals new car, you're going to find that you can't do this because it's abstract. So that's the point of abstract, is it's not fully defined, so you can't create an instance of it because there's unknown aspects. So we now have an abstract class called car, and as we mentioned, we're going to make the presumption that all cars have the radio turned on the same way. So I'll just make a function. So public void radio on, and then what we'll do for this is just simply do console.writeLine for everything, and we'll simply say turn the radio on, and there's a function. Now in an abstract class, or in any class really, you might want to allow the classes that then subclass this to override and make new versions of this function. So by default, as we mentioned, all of the classes that inherit from car will get this function by default, so they won't have to implement it, but then they might want to specifically say upgrade the radio, and then they want to turn it on differently. So in order to allow this to be changed in future classes, you prepend this with the word virtual, and you'll see this once we've finished the lesson. You'll see how we do that. So virtual allows, say, a public class budget car, which implements car, to now do override radio on. And then here we can either call the original function, or we can completely replace it with our own function and do something different. So we'll come to that in a minute, but that's what it allows you to do. So then whoever calls the function, you can call the specific one. So we've got the radio on, and we'll quickly wrap this in a region for public methods, keep things clean. And then we'll even comment, so an abstract definition of a car of any kind turns the car radio on. And then we said also the handbrake will be released the same way for all vehicles. So again, we'll make a public virtual function void, says handbrake off. So, or let's rather release handbrake, makes more sense. Attempts to release the car's handbrake. And then in order to do that, we need a property. So let's just make a properties region. And here we'll put a public boolean handbrake released. and by default the car's going to have the handbrake on, so it isn't released. So then, in order to release the handbrake for all cars that we're saying by default is the same, we would then do handbrake released equals true. Simple as that. And then we would mention that we managed to do that. So we now have the radio on and the release handbrake functions implemented. And the last one we said was in order to drive, which is to press the gas pedal and drive. So again, a public virtual void of a drive function goes on the gas to drive the car. And then here now, and again, remember this is all demo code. I don't typically like to do demos this way where it's a fake thing that isn't really in programming. But this is just a really good way to explain abstract classes. Then I'll show you some real world examples again of where it's actually used. But this is a good way to explain the concept. So the point of this is these three functions are going to be the same for all cars. And then yes, we can override them with virtual to make them specific. But at least it's, if it's not implemented, it's classed that this car will have the same, way of doing that. So same for like a handbrake, you release them the same in every car. And then when you get to luxury cars, you might have an electronic handbrake. So it kind of follows suit, but it's easier to grasp this way. So for the drive, in order to drive, we first need to release the handbrake. So we'll say release handbrake. Because you can't drive if your handbrake's on. Well, you can, but you'll burn your brakes out. And then we'll do a check with if the handbrake's released, then we'll be driving. So we could then go on the gas. So we say press the gas pedal. Otherwise, if the handbrake didn't release, then we'll say cannot move, handbrake jammed. And that's how we'd then drive the car. So we've got the three functions that were in green on the presentation at the start. So these are the three functions now that we'll copy to every car that implements this class. So they won't have to redo these functions. These will now work. So that's them out of the way. Then in order for, there's certain things now that we're going to say we simply don't know. We can't make a presumption that all cars act a certain way or have a certain thing. So one of those things is we're going to say the wheel size. We can't make a presumption because every car's got different wheels. So we're just literally going to leave that as an unknown. But we do know a car has wheels. So this is where we're talking about an abstract class, is that it's a known thing. So we know that the handbrake is released or it's not released. And we know we can turn a radio on and off and we can drive. And we know a car has wheels, but unlike being able to turn a radio on and off by default or release a handbrake by default, we're going to say that the wheels we simply don't know, but we know for a fact it has to exist. So this is where you define an abstract property in this case. So this is going to be a property that we know all cars need, but we don't know anything about it. We don't know the value, we don't implement it. So you define it just like a normal variable or a normal property in this case, and we'll call it wheel diameter. And it's going to be in inches. And it's going to be a getter only. So the car's wheel diameter. Now that's a normal property. Now if we do instead abstract here, this means now that any class that implements car is now going to have to not override, but actually create this integer. So it's forcing the class to implement a wheel diameter. So if we then we might as well then go ahead and start making a public class budget car. And you'll see now it's saying budget car does not implement inherit abstract method member wheel diameter inches. So you can click on there and you can click Control and dot, and then you can press enter to implement abstract class. And you can see it's forcing us to implement the wheel diameter inches. So in this case we'll return say 16. So this is a way that if we now make an instance of a car, we create a subclass of car, then we're going to be forced to implement the wheel size. And that's kind of, and then one of the points of an abstract class is to sort of force anything that wants to implement it, you can be forced to implement specific things. So we implement in the base class, in this base abstract class, things we know about that we want functions of, and these can be anything, but then there might just be a few small things that we don't know about. So instead of having to copy the logic all the time and redo a load of logic in every class, you can simply define something that's known but we don't have the value for, and then you can make use of that inside of functions without having to have the explicit value. So it'll come clearer as we finish more things off in here. So we're going to add another few things. So we will have, in order to calculate the speed, originally in the slide we had it so that each car was going to calculate its own speed, but really we can calculate the speed of the car by simply having the wheel diameter given to us and everything else is the same. So unlike the slide where we had calculate speed as an abstract, we've changed that to wheel diameter as being an abstract, and we're now going to implement a calculate speed function that's going to return a float. We'll call this calculate speed in miles per hour. And this one isn't virtual because we don't want the calling class, this budget car and sports car, to be able to replace this function, because this is a known mathematical function. So we don't make it virtual, so therefore it can't be overridden. So it's just a regular class function like any other. So to calculate the speed, well, one, if the handbrake isn't released, then the speed is going to be 0 because we're not moving. And that's the presumption we've made, because the drive won't drive until the handbrake's released. So if there's no handbrake, well, the handbrake's on, we are not moving. Otherwise, we then want to first get, in order to calculate miles per hour, we've got the wheel, which is in inches. So this is nothing to do with abstract classes, really. It's just some mathematical equation, so I'll kind of skip over it fairly fast. But we want to first get inches per revolution. So basically, how far, distance-wise, along the road we would travel for every rotation of the wheel. So that's a fairly simple math equation for anyone that knows any kind of math. And that is just the diameter of a circle, which is pi times the diameter. So this will convert, say, a 16-inch wheel into like a 48-inch flat surface, roughly. So you'll travel 48 inches every time the 16-inch wheel has done one full revolution. So that's the first part of the calculation. Now you want to get the inches you will travel per minute. So you've now got inches per revolution. So now you want to know how far you'll travel in a minute. So in order to do that, you get the inches per rev. And you now need to times, and you need to know, at this case, what the gearbox is outputting in order to, because the gearbox spins the wheel. So the engine spins, which then goes through the gearbox, and then through a ratio it comes out and moves the wheels after it's gone through a differential. But the basics are, we need to know the output speed, the revs per minute of the gearbox. So let's just also make a quick function here called public float gearbox output speed revs per minute. And again, don't worry, this is not really specific to abstract classes, but we'll fill it in so we get some functionality. So we're just going to say my gearbox is spinning the wheels 1,000 revs a minute. So then if we times that by gearbox output speed, we'll now know how many inches a minute the car's traveling based on the wheel size and the gearbox, which is now going to stay fixed. This car's going to drive with the engine and the gearbox spinning at the exact same revs all the time, just for this demo. So the final phase there is to simply convert it to miles per hour. And to do that, you just want inches per minute into inches per hour, so times 60. So now you've got inches per hour. Now you just want to convert inches to miles. which is by timesing it by a small number of, I think it's 1, 2, 3, 4 zeros, 1, 5, 7, 8, 2, 8, which is kind of sad that I know that number as well. And I think that's right. So that should convert inches per hour into miles per hour. So once we've got that, we return the miles per hour. And that's now a function we can call. So we've now got some functions we've implemented. We've got the radio on, the release handbrake, the drive. They can all be overridden with new functions. Then we've got standard methods that are basically the gearbox speed and the speed the car's traveling. So that's them in there. And then the other two things we said in the slide, the abstract parts of the car, the things we don't know anything about. One is this wheel diameter, which is a property. And the other two are going to be functions. They're going to be methods. And that's 1 to wind the window down and 2 to move the seat forward. So again, just like you create a normal method, which would say be public void wind window down. That's how you create a normal method. To make it abstract, like everything else, just put the word abstract in front. And now you should see that you don't want to implement an abstract. So because you don't know anything about it, you don't implement the method, you simply put a semicolon. So now this is an unknown method. We can certainly call the method inside of this class, but the actual implementation of what that does is not known, and it doesn't need to be. So it can't, because you can't create an instance of an abstract class, it doesn't matter that this could call it in here. So you could say in here, wind window down. But this class has no idea what wind window down does. But it doesn't stop it effectively calling it at this point in time, because whenever radio on is called, it can't be called from car. It has to be called from, say, budget car. So therefore, you can add logic into your abstract class that makes use of unknown information. So again, I'll try and point out some good real-world examples after this of why it's useful. So this will wind the car window down, and it's not implemented yet. And then we'll also have the abstract void move seat forward. Oops. Keep spelling forward wrong. There we go. So these two now, you'll see here, need to be implemented. So click budget car, control dot and enter. And you can see now it's implemented these three things. So now any car that we create, again, as the diagram shows, we now need to implement these three things for it to become a full car that we can make use of. So we don't make any presumptions of how a seat moves forward in any car, so we then have to implement it per car. So in here, again, we'll just do console.writeLine, moved seat forward using hand lever. And then the wind window down, console.writeLine, wound window down slowly using, I don't know, winder, whatever you call the manual lever. So this is the budget car implemented. So now in here, we can do var budget car equals new budget car, and we can create a budget car. So now we have an instance of budget car, and then we want to make use of that. So we will have, say, we'll do console.writeLine, budget car, and then we'll put some like underlined type of header there. And then we'll create the instance of the budget car. And I don't know, let's say do stuff to car. And we'll pass in budget car so that we can, do this exact same thing for the sports car afterwards. And then in this function, do stuff to budget car, we're not going to pass in budget car, we're going to pass in the abstract class, because that's all we need to know. The abstract class contains all the known, that it contains the methods, and we can now call them. It's just that you can't create an instance of car. So by passing in an abstract car, we can make use of this function for any kind of car and still call the methods that are specific to like budget car. So in here, we're just going to say, I don't know, move the seat forward, put the radio on, wind the windows down, and drive. And then we will log out the speed the car should be driving at. So we will say driving at whatever miles per hour with something inch rims. So then in here, we will be driving at car.calculate speed in miles per hour and car.wheel diameter inches. So we'll basically output some information about the car. Once we've done that, we'll simply wait so the console doesn't close. And if we run this now, we should see that we've moved the seat forward, the radio's on, we've wound the windows down, and we drive. So you can see, move seat forward using hand lever, turned on radio, wound window down slowly using winder, successfully released the handbrake, pressed the gas pedal, and we're driving at 47.59 miles an hour with 16-inch rims. So there's one car done, and all we've had to do to get all the methods of calculating speed and turning radios on, we haven't had to redo that in the budget car. We've just had to specify the specifics, the things that are specific to the budget car that are different per car. So now we've got that one, we can make then public class sports car. Click Control dot and enter. Wheel diameter, this one's going to have big 22-inch rims. Move seat forward, we will have move seat forward using button. Nice and easy. Wound window down, fast with electric motor. And that's all that's different. That's all we've got to do now to make a sports car. So in here, we can copy the budget car output and do a sports car output. And then this will be sports car equals new sports car. And this time we'll do stuff to the sports car. And then if we see the output of that, we should see all the standard stuff like turn the radio on is the same, and it's come from effectively the base car. And we have move seat forward using button. We're driving at 65 miles an hour because the wheels are bigger. But in essence, all the other stuff is the same. So we've managed to get, and in fact, we'll also do just a new line so that we have some space between there. So we've got two different cars that we've just had to implement, the specific functions, and then they've gained all of the properties like the handbrake release, the methods, and everything else from the base class, and then they just have to implement specifics that are for the abstract class. So I'll do one other example here. We'll say we'll make a broken budget car. So we'll do a public class. In fact, I will just copy the budget car once more, paste it, and we'll call this one broken budget car. And we got all the same stuff, which is fine. So that's okay. We don't need to do anything about that. Or rather, let's just simply inherit the budget car, and then we don't need to do that at all. So we've got a budget car. We're going to make another version of it that's now broken. So for that, we're going to now override, and this is why we made the other functions virtual. We're going to say, in this case, the release handbrake, we're going to make this our own function in this broken version because we made the function virtual here, which means we've got an implementation, so we don't need to implement it, but there's an option that we can. It's not like an abstract where we have to implement. You've got to make an instance of this because nothing exists. A virtual method exists, but you can simply make a different version if you like by overriding. So in the budget broken car, we're going to override the handbrake, and we're simply going to say the handbrake released as false. We're never going to release the handbrake. So handbrake is always on. And then we're going to do console.writeLine exclamation, because it's an error, handbrake failed to release. And then we're going to see what impact that has now. So in the budget car, we're going to change it to a broken budget car. And we're going to run that. And you can see now we've moved the seat forward, we've turned the radio on, wound the window down, and it says here handbrake failed to release. And now cannot move, handbrake jammed, driving at 60 miles an hour, driving at 0 miles an hour with 16-inch rims. So effectively, we have implemented a budget car that now doesn't release the handbrake. But when we tell it to drive, which we haven't told it how to drive here, it's picked that up from the abstract class. It's figured out that, it can't move because the handbrake's jammed. Ooh, that should be right line. So that's really the abstract class here as car that implements things that are the same for every car, like, calculating speed. But then it needs to know specific information about, the master classes, or the classes that implement the abstract class. So that's all good and true. That's how it's physically done. And in essence, you just stick the keyword abstract before what you want to be abstract, and that makes it abstract. So I guess one of the questions might be, why would you use an abstract class, say, instead of an interface? Why not just make all cars have an interface with wheel diameter, handbrake released, radio on, all this, that, the other? The key thing with an interface is you can't implement anything in an interface. So if you make an interface, then you can't make any instance, you can't define these functions because an interface is not a definition. So you wouldn't use an interface because we want to explicitly define these methods, the known pieces of information that we want to implement. So that's why you wouldn't use an interface. So then the next question might be, well, why wouldn't you just make a base class? Why do you need abstract? Well, if you delete the word abstract, now you've got to then define, you can't then do abstract inside because it must be contained in an abstract class. So you'd have to remove abstract from here, which now means you have to define wheel diameter, which by default is 0. So that's not going to break anything. And then you'll come down and these functions are then abstract again. So you'd have to delete abstract. You'd have to make versions of those methods. And now you could create an instance of a wheel car. You could create an instance of car, which is, no longer abstract. And you could attempt to, do things with it where the wheel diameter is 0, so it's not really valid. A car can't have 0 diameter wheels. And also, when you come to, say, make a new version of the car, so if I did public new car implements car, or public class would help, you can see now I get no warning. I get no prompt to even do anything. So now the person implementing a car might say, oh, that's all cool, I've now got a car. They then got to go and figure out, well, what's on the car? Oh, let's have a look. There's, you're getting all the class properties, you're getting a load of stuff. It's like, well, what do I even do? What's, they might start typing and try and find out, I don't know, public override and see what they can do. Or they might have to then create a constructor and do, oh, look, there's wheel diameter. So they're going to have to figure out, how to do things. It's not the same. So you're giving no indication to the implementing class of anything that's expected. You're not forcing a behavior onto being implemented. You can also then just go and happily create a new instance, as we mentioned, of car, which is not really valid because it's a partial definition. It's got partial unknowns in it. So the reason why you wouldn't use a base class is basically because there's functions that you want to force onto the implementing class. So you're expecting them, you're forcing these things that you need to know explicitly on the class. So it simply would not work without that in there. So we just run back in time to when the class is abstract. You're now forcing these on. So if we didn't implement a wheel size and we were trying to make a new instance of the car, it literally will not compile. It's a very forceful way to make sure anything implementing a car it's going to implement what you need it to and your expected things. And the second reason for an abstract class is also to make sure you can't create an instance of car, because it's partially unknown. So it's not that you can't use a base class, because you can do everything with a base class that you can with an abstract. It's simply that an abstract is a more appropriate way of defining what you expect this class to be, and what information you need from it. So that's how you create an abstract class, then how you'd implement the abstract classes and how things are different on them with some output. And now I'll just go ahead and open a few things that are, again, real-world examples where we are actually using them in some code. So I'll go ahead and open those now, and we'll take a look. So the only real example I could find, because we don't use them that often, is this base attached property in the Facetto Word application we're building. And here I make an abstract class for base attached property. We don't do any abstract properties or methods because there's nothing we explicitly need from a class that subclasses this. It's more that we add all of this logic into the class. We define, a value itself, the attached property. We do all of the complicated stuff. And the key thing here then in the abstract class is that we simply make some virtual functions, or in this case, virtual functions. And it's when the value changes and when the value updates. And by default, we make them nothing. So nothing happens when the value changes, which is perfectly valid. But you typically expect to override one of these two things. So we could make them both abstract and force both of them to be implemented, but then you'd often have one of these blank. So in this instance, we make two virtual methods in the abstract class, and that's all that has to be done by then classes that implement this. So they inherit all of this code, and they can simply now implement the base attached property. So an example of where this is then used, we scroll up and look at references. We have, that was a bad way of doing it. Let's do, where are we here? So let's say auto scroll to bottom property. And it implements a base attached property. And we pass in, this is also a generic, so we pass in ourselves. And then we override, like we saw in the example, this on value change. So when the value changes, we do something specific. And that's all we care about. So now, in order to create an attached property, all we have to do is override this abstract base class. And that whole thing will link up and work. And whenever the value of that attached property changes, we override the method to then do something specific. So it allows us to make very small and clean attached properties by using this abstract base class. And again, if we didn't make it abstract, that would mean that somebody could try and create a base attached property, which wouldn't really work because it's not designed that way. So this is an actual working example of what we use. And the reason we've chosen this over, say again, the two definitions are, why would you choose an abstract class instead of an interface or a base class? Well, you wouldn't choose an interface because you couldn't define all of this data. And you wouldn't choose a base class because we do not want the base attached property to be instantatable, if you will. You don't want to instantiate a new class because this isn't by definition complete. It's not going to do anything. It's just generic. So you attach this. What's it expected to do? Nothing's been defined. There's no behavior in the on value changed or updated, which is the point of it. So you don't want to instantate it. And there's functions that we want implemented, which we're not forcing with abstract here because the user can choose between one of two, or they can simply do things on both. But we could have quite easily made these two abstract. But again, there's no need. We've made them virtual so they can be overridden. So an abstract class doesn't need to have abstract content inside of it. By doing a class like this, the main benefit is they simply cannot create a new instance of base attached property. And again, that effectively defines the expected usage of this class. You're telling the developer that if they try and create a new instance, that's not the right way of doing things. You haven't made this class for that reason. You've made this class purely as a base class, and you're forcing that by putting abstract there. And then on base classes that are abstract, the developer then knows to look for, overridden methods. So if I was going to then implement an abstract class like this one, if I then did public class A, and it was a base attached property of A and a boolean, and I know it's an abstract class, I'm going to then just simply type the keyword override and see what I've got. And these are object, because every class is an object. So that, and to string are all built in. And I can quite clearly see now, these are two things I can implement on that base class. So that's kind of, again, what developers are expected to do. If you implement an abstract class, the first thing you'll do is you might be forced to implement certain things, and then you know about them. And then the second is to type the word override and have a look at, right, what can I do with this? And these are the two variants that you can do. This is the only two things you can really change about the class. So therefore, that's kind of the intended purpose of this abstract class, and it's been given via either forcefully having to implement abstract things or in the override keyword. So that, in short, really is what abstract classes are and what they're used for. Again, you don't use them much. In fact, this was the only real example I could even find where I've used them recently. But they do have a purpose. Again, they can certainly be done. You can do everything without abstract. It's not a requirement. It's simply more of a defined intent to, force the correct usage of a class that you're making. So hopefully that's been, I guess, the best way I can explain an abstract class, because they are, fairly specific, and they're simple, but they're also, they've got the key purposes. And one is that they shouldn't be created on their own. They're not designed to be used as is. And the second is to force any class that implements the base class to correctly set up, instantiate, and work correctly with that class. So again, any questions, anything unclear, just simply leave a comment. But hopefully this was useful. And yeah, that's it.